Welcome to The Explainer. Today, we are looking at something absolutely fascinating. When we think about the future, we usually picture massive green grids and endless energy storage, right? But today, we're uncovering the hidden vulnerabilities of the fuel cell and industrial battery supply chain. We're going way beyond the glossy surface of green tech to examine the physical nuts and bolts, and more importantly, the massive risks that could literally hit the brakes on this entire global transition. So, what is the hidden bottleneck threatening the future of clean energy? It's really easy to assume that because solar and wind energy are everywhere, the tech we use to capture and store them is equally unconstrained. But pose this provocative question to yourself, because while clean energy is undoubtedly the future, it currently relies on a very, very fragile foundation. You could have all the engineering brilliance in the world, but if you can't get the raw materials to actually build the battery, the whole system just grinds to a halt. And that brings us to the core premise of today's explainer, the geopolitical bottleneck threatening clean tech supply chains. We are looking at exactly how geopolitics and materials sourcing crash into each other to create massive systemic risks. We aren't just talking about a temporary passing shortage here. We're talking about deep structural vulnerabilities, where the exact materials required to build industrial batteries are locked behind complex global borders, regulations, and localized tensions. Okay, let's dive into this. To really understand what's happening, we're looking at our primary source for today's analysis, the SASB standards, which is now part of the IFRS Foundation. This framework is essentially the ultimate blueprint for measuring sustainability risks. We're using the specific SASB standard for the renewable resources and alternative energy sector, zooming in heavily on fuel cells and industrial batteries. And this isn't just theory, folks. This is the exact standard that investors and big corporations use to quantify supply chain risks and determine if a company is truly built to survive the clean energy transition. Here is a quick look at our agenda today. We'll cover the clean tech bottleneck, define what critical materials are, look at supply risks and geopolitics, discuss the financial impact, and wrap up with mitigation and recycling strategies. Let's kick things off with Section 1, the clean tech bottleneck. The SASB standard puts it pretty bluntly. It states, access to these materials is critical for the continuous development and scaling of clean energy technologies. I really want to emphasize that word, critical. The entire green energy transition is 100% dependent on a highly specific, very vulnerable supply chain. If these manufacturers cannot consistently access this exact set of metals and minerals, the scaling of alternative energy simply stops. It's that straightforward. Moving right along to Section 2, defining critical materials. So what exactly makes a material critical? Well, according to the SASB standard, a critical material is something that is both essential in use and subject to the risk of supply restriction. Notice that it's a two-part equation here. It isn't just that a manufacturer really needs it. It's that incredibly high necessity combined with a restricted supply. I mean, if it was essential but super easy to get, it wouldn't be critical. And if it was hard to find but no one really needed it, it wouldn't matter. It is this dangerous combination that creates the bottleneck we're talking about today. We can see exactly which elements are causing this logjam. The standard specifically highlights lithium, cobalt, and nickel, literally the lifeblood of modern battery tech. Then you have the platinum group metals, things like platinum, palladium, and iridium, which are absolutely vital for fuel cells. We also have a whole host of rare earth elements, including yttrium and scandium, plus materials like antimony, graphite, and magnesium. Battery and fuel cell manufacturing relies incredibly heavily on these exact elements. You just can't swap them out for something else without fundamentally altering the technology and tanking its efficiency. This brings us to Section 3, supply risks and geopolitics. Here is the harsh reality. Global resources for these critical materials are not spread evenly across the map. As the standard points out, they are heavily concentrated in countries with limited governance or high geopolitical tensions. Think about that for a second. When a huge percentage of the world's supply comes from a handful of very tense regions, any localized issue, like a trade dispute, a sudden change in local law, or a regional conflict, instantly sends massive shockwaves through the entire global supply chain. Now let's dive into Section 4, the financial impact. So what happens to a battery company's valuation when it suddenly cannot source cobalt, or when the price of lithium just triples overnight? The SASB standard breaks this multi-layered financial threat into a really clear matrix. First up, physical limits. Sometimes the material just isn't there or access is totally cut off. Second, price changes. High input price volatility can completely wipe out a company's profit margin in a flash. Third, regulatory risks. New laws popping up in those extraction zones can change the cost of doing business overnight. And finally, reputational risks. If a company sources materials from a region with unethical labor practices, the damage to their brand value can be catastrophic. And this brilliantly illustrates that we're looking at a severe financial and valuation vulnerability here, not just an environmental issue. To summarize the core financial threats, supply disruptions and volatile input prices directly threaten clean tech company valuations. And actually, to make matters even more complicated, the SASB standard explicitly notes that competition from other industries just exacerbates these exact resource constraints. Fuel cell and industrial battery makers aren't just competing with each other, they're competing with the consumer electronics industry, the auto parts industry, and basically anyone else on the planet who needs lithium or rare earth metals. Which leads us to our final part, Section 5, Mitigation and Recycling Strategies. Fortunately, the standard lays out a pretty clear risk survival guide for clean tech companies, identifying 4 absolutely crucial mitigation strategies. Step 1, diversification of suppliers. Basically, don't buy all your critical materials from one politically tense region. Step 2, stockpiling of materials, building up your reserves to weather those sudden price spikes. Step 3, development or procurement of alternative materials. You have to innovate so you rely less on the most bottlenecked elements. And step 4, investments in recycling technology. This last one is incredibly important, as it completely changes the entire dynamic of the supply chain. Let's actually draw a direct line between the problem and the solution here. We have the materials sourcing problem, those global resource constraints and geopolitical disruptions we just talked about, and that is directly offset by the end-of-life management solution. The SASB standard makes it abundantly clear that as more industrial batteries and fuel cells hit the end of their lifespan, designing them for easy disassembly and recycling is absolutely paramount. Building a highly recyclable product physically offsets geopolitical supply chain disruptions. Because if you think about it, every ounce of lithium or cobalt you recover from an old battery is an ounce you don't have to go navigate global geopolitics to buy. Because of this massive offset, the SASB standard requires companies to track these specific end-of-life metrics. Investors want hard data. They want to know the percentage of products sold that are recyclable or reusable by weight. They want to know the total metric tons of end-of-life material recovered and exactly what percentage of that was successfully recycled, reused, or reclaimed. And crucially, because batteries contain solvents, corrosives, and nasty stuff like sulfuric acid or cadmium, investors demand absolute transparency on the proper management and disposal of hazardous waste. These aren't just feel-good environmental metrics. These are the exact data points that tell an investor how resilient a company actually is against the geopolitical bottleneck. Which leaves us with this final, truly provocative thought to end on. As the clean tech transition accelerates, is your supply chain resilient enough to survive the bottleneck? Look, the transition to green energy is unstoppable, for sure, but the path is entirely dependent on mastering this incredibly complex balance of sustainable technology, corporate valuation, and global geopolitics. Thank you so much for joining me for this explainer, and I really look forward to exploring our next topic with you soon.